Good day, everybody. Thanks for joining me on this talk about KNX and the latest evolutions as regards KNX IoT, a standard for home and building automation constantly on the move. So what you see here is the content of my presentation. First of all, I will give you a overview of what KNX IoT is about. I will explain you the aspect of semantic project export within the KNX IoT project. I will explain you what the third-party API is about. I will explain you what the point API is about. And then I will briefly give you an outlook on the further progress we want to make in this particular project. So this slide is a bit crowded, but it explains in three specific blocks what the KNX IoT project is about. The KNX IoT project is about extending the current KNX system with new possibilities that do not exist in the classic system, but which can be built on top of the KNX or the current KNX system. The first block within the KNX IoT project is the so-called third-party API. So it's an interface for third parties being typically non-members of KNX wanting to tap into KNX data. So it's a possibility for non-KNX products and or cloud services to access data from a KNX installation via a manufacturer-independent REST API. The data exchange is based on a client-server communication, so meaning that for being able to hook into the data, you need a KNX IoT third-party gateway. And the idea is that this gateway can be configured based upon an export file that is created by the ETS, the so-called KNX Semantic project export. The description of the third-party API, as you are accustomed to in KNX, this is documented in a PDF file, so in a document, but it uses also OpenAPI to describe this interface. And there is even an electronic counterpart to that, the so-called YAML file. The second block, I'll jump to the blue part in the slide. The second part, or the second extension within KNX IoT, is the so-called point API. The point API is so to say, an extension where devices again interact with one another, so sensor-actuator communication, but based on or using IPv6 networks to communicate to each other, to exchange data, as you can also exchange in a KNX current system today. So data related to lighting, to solar protection, to HVAC, to energy management. Also, like in the classic system, it is intended to on these IPv6 networks to also ensure efficient group communication, as you know that from KNX Classic. So one sending device addressing a one or many recipients. The idea is also that the semantics of the data will also be exchanged between devices, but they will mainly reside in the devices to keep the communication as slim as possible. I already mentioned the semantic project export. What is this semantic project export? This is a description containing linked data that links information about the location, the devices, the application functions, and the interdependency with the physical world of things realized in a KNX installation. So it answers questions like what devices are in this installation, where are they located, what functions do they realize, lighting, blinds, HVAC functions. And it also gives a hint by means of tagging information about what the actual device or the actual thing is that is connected to this KNX device. So ETS will export this information in a JSON linked data file. So it will not be an XML file, as you now know from ETS export. It will be a file that uses the JSON LD format. Why do we create all of that, these extensions towards IoT? Because we want to, because KNX provides a lot of data that may be the basis for providing services based on this data on cloud applications that do not directly sit inside the installation, but on some cloud server. So things that could be realized are analytics based on this data, optimization of operational efficiency, predictive maintenance, visualization, etc. So all based on this rich KNX data. This slide provides you an overview of the whole project. So if we take the block here at the left-hand side, so this is the world you typically know today, a device in the KNX Classic system. Such a device and the data it generates or holds would be accessible via this third-party API gateway that provides to a third-party client in JSON the relevant data. On the other side would be these sensor actuator communication based on IPv6 networks, which we refer to as KNX IoT Point API. This can be devices or brokers. So here a broker is shown and here a device. Between those two devices would be this sensor actuator group and pub/sub communication. The idea is also that future ETS will be able to also, of course, configure these devices, like you can configure twisted pair and radio frequency devices today. And ETS also would be able, from the project, to create a semantic project export that allows to, in the first step, configure the gateway in a manufacturer-specific way, but in a second step, even a ETS standardized way of configuring this gateway. The same story, but maybe in a different shape. As you may, some people may say, well, I thought that KNX could already provide the possibility to connect to a KNX installation via IP. Yes, that is absolutely true. This already exists for more than 10 years. This is referred to as KNX Net IP, but this is a system that, or this is an extension to the classic system that tunnels a KNX frame on top of UDP. So the entire data is still a KNX frame. It holds all the relevant data of a KNX frame. There are many system providers that provide such commercial stacks to make a product KNX Net IP compatible. And these products can also be configured in ETS, but as I said, this is a system that transports the entire KNX frame across IP networks. So as a direct extension of twisted pair and radio frequency. So this third party interface would allow to connect with a gateway to a classic installation. So it provides the data as well as the meaning of data, the semantics of the data of this installation. And this data is organized, is defined, or is documented in a KNX information model or an ontology, which is also part of the KNX standard specification. So this third-party interface allows anything that is not KNX to simply listen to the data as well as the semantics, not the entire frame. So for actually understanding this data, you do not have to understand the intricacies of the KNX Classic system. Here is this point API extension. This point API extension is, as I said, a sort of an IP field bus communication that indeed, again, has data as well as semantics, but the data is not exchanged via the normal KNX frame as you know it, but it is the protocols that are used for that are completely come from the IT world. So exchange data is exchanged via HTTPS and co-ops, no longer a specific flavor of KNX. So the data is still KNX, and the way that the devices are commissioned is still KNX, but all the underlying technology comes from the IT industry. What I just formulated is again shown here, depicted as communication stacks. This is the third-party API. This is the point API. For the third-party API, a gateway could communicate via Wi-Fi or Ethernet on the physical side, would typically use HTTP, would use unicast TCP, and could be IPv4 or IPv6. On top of that is the IoT third-party API. A point API device, so a sensor actuator communication based on an IPv6 network, could use any medium that is typically used for constrained devices, amongst others, thread, for instance. It would use the application protocols co-op, and we are also looking into OpenWeave. This is still a possibility. This is not yet fully decided. Communication would be unicast via UDP or TCP, and multicast would be UDP. Where are we on well, on describing this system extension of KNX. The yellow depicted parts are fully approved standard. So there is an introduction, of course. There is a description of the information model, so the ontology, as I just mentioned. There is a full description of the KNX IoT third-party API. And there is a draft proposal. A draft proposal in KNX speak means that this specification is undergoing a first vote of the KNX technical board. So normally a specification is submitted to 2 voting cycles before it is published as an approved standard. So for the communication sensor actuator communication based on IPv6 networks, this is still a draft proposal and contains 3 further parts and an annex. Okay, this semantic product export, what information does this contain? And I think this is very well shown here by this by these puzzle pieces. So the information model, the standardized KNX information model described in the KNX standard, answers is able to provide you answers to questions like, where is my device located? So you see the device taps into the location. And which points, which data does it host on it? So via its application program, of course. And these points, to which application function do they belong? For instance, a point could be a set point temperature. This would then belong to an application function related to HVAC. And also through this, we would know where this set point actually applies. Is it the kitchen or is it the bathroom? And also which feature of interest is observed or affected by the application function or the point. This feature of interest is actually the relation of the point and the application function towards the physical world. So are we looking at the set point temperature of the air? Are we looking at the water, or are we looking at maybe another physical medium? All of this is contained in this semantic data that is exported out of ETS. We are aware that KNX and with the current product databases we have, some of the semantic data that we want to expose on the third-party API is there. Some other data may still be missing. That's why the manufacturers have decided that we are going to work to extend the semantic product description that is available as part of the product data, or maybe as an extension to the current product data. So that when the system integrator configures a product in ETS, this semantic data is already there. And he does not have to complete all that data, because completing all that data would imply a lot of work. So we want this data already to be there as much as possible, so that most of it can be exported towards the third-party gateway. So for this, the manufacturers and KNX have started a new discussion group where the whole flow will be described to improve the whole ETS engineering workflow and also the semantic project export. Why do you think we would put all this effort in actually enriching the data of KNX? Well, this is all to be seen in relation with the so-called building information modeling. BIM is really taking shape in buildings today, because this has proven to improve considerably the efficiency of working in the whole construction industry. It allows to find much more earlier conflicts and errors. The budget is much more reliable. So it's not more guesswork, but by having more data, the budget reliability is increased. Even there are fewer accidents on the job sites. The project is quicker in being delivered. The life cycle costs also, well, a building is not only constructed, but also it has a whole life, and also this life cycle involves costs, and BIM data considerably increase this life cycle costs. And the quality of the building is much higher when based on BIM data. If you look at all the parties that are involved in the building process, you may see a number of target groups that actually KNX addresses with its ETS tool. For instance, the installer and the system integrator, and also to some extent the building operator, is affected by the quality of the data that we provide to them. So there is a general trend to strive to digitalization of functional descriptions of products. There is a standard. This is the former standard number, ISO 16484-4. There is a new standard. There's an EN standard which is being made today. That is the EN 17609. This will, for building automation, standardize functional descriptions of products. So KNX is ideally positioned of having a common manufacturer independent tool, the ETS. And if we provide semantics on top of that, we will be even better positioned in the building automation trade. Okay, there are a number of decisions which have been recently taken by the executive board of KNX. The executive board of KNX has decided that we have created a specific web page for anybody interested in the third-party API. This web page is called schema.knx.org. It's already live as we speak. This web page provides anybody wanting to design a third-party API server or a client. He can read about the information model. So the information model I just described with these puzzle pieces. So you can read about that. Also, if you're a non-member, we provide the open API description, and we also provide the KNX standard describing the third-party API. We also want to describe in international standardization, we want to describe this information model. And actually, a first version of this information model was already submitted to international standardization. We have submitted that as part of the EN 50/90-6-2. This PREN will be updated, or is being updated as we speak, by the final version, and will then also be available for even persons not visiting this web page. So what work do we still want to do in the next months? For the third-party API, we have already created the necessary entities for devices, so to connect to entities directly related to devices. But we still need to start the test and certification specification. This is the next step to be done, because we want to also offer, as KNX, we want to offer manufacturers the possibility to test and certify their devices. As regards the semantic export, we will validate and extend the tagging catalog, and we will, together with the manufacturers, validate the ETS export file. And we are also developing a proof of concept as KNX. I already mentioned that we will also update the PREN standard. And as regards the point API, we have a subgroup of manufacturers meeting on a weekly basis to continue working on this point API. And the first work will be of this group to resolve the comments that will come from submitting the draft proposal to voting, which is currently being voted as we speak. Maybe some words about the point API. The point API, for the point API, we want to work in two steps. We want to have a two-step approach. The first step, as regards configuration, is that we want to make sure that the ETS in some future version is able to configure the security of such a KNX IoT device. This is seen as a first step, as well as being able to load the group tables or the assigned group addresses that the tool allows you to download that in a KNX IoT device. This sounds logical because you are very used to that in the current ETS, but of course, for the time being, you cannot yet do that for a KNX IoT device. And as a first step, we want to realize in the point API the possibility to use group communication for constrained devices with reliability requirements. So such devices would send notifications to pre-configured recipients, that would be brokers. And as a second step, we would like to realize constrained devices with low latency requirements. So the devices would then send notifications via multicast to recipients in the same local network. So this is the first step. This is the second step. And the point API would also allow to subscribe and notify. So a edge device or a broker could subscribe and be notified about changes on the data of the KNX IoT device. Okay, this again shows the same information. Actually, what I have just explained in the previous slide, but in a different representation. So This group notification event, this would be a device sending this out. I mean, a little bit similar to what we know today on twisted pair or radio frequency, and a edge or a broker device subscribing to points of a certain device. So the device informs when these values change. It notifies the broker of any change. And of course, there can also be a link between this block and this block. Also, again, another representation of the same information, but now shown with real devices, and also showing you how a classic installation could be extended, for instance, by a mini thread network where devices are inside that use the KNX IoT Point API. So actually a room unit on twisted pair could, via a Point API gateway and via group communication, even switch on a lamp that is sitting on a thread network behind a thread border router. And all of this would be configurable in a future version of the ETS. So as you can clearly see, IoT really builds upon what is already there today. So it's not a just replacing of one by the other. It is extending the current KNX system with new possibilities. Okay, so as a last information, what is the further roadmap for the different parts of the IoT standard extension? So this is where we are now. We are already in February, but let's assume that this is February. So in October, we finalized the KNX information model. We finalized, or we finally voted, or we final voted the third-party API. Both sections were approved standard or published as an approved standard. So you can find this on the schema.knx.org. As regards Point API, the group readied the draft proposal, and this draft proposal is also undergoing voting as we speak. It is expected that this draft proposal will need 2 more voting cycles, and we hope by the end of 2021, beginning of 2022, that this Point API is available as a final specification, so also as an approved standard. For the information model, we want to continue working on improving the semantics and improving the export possibilities from the ETS. Of course, we will have to do some maintenance on the API. This is unavoidable because of, for instance, defining the certification tests. We are bound to find some glitches that we will have to improve. And after that, of course, we will. This will never be a final project. This will be continuously improved and extended with or following needs from different manufacturers. Thank you very much for your attention, and for any information on the IoT project, you can contact the email addresses that are given here at the bottom of this slide. Thank you very much, and enjoy KNX IoT. Thank you.